need some sheets for check.
Here we got support. There's a pair. And we did the second. There's the two rectangle ones. We did the second one. And now I just put up the first one.
Okay, that made a lot more sense because normally I was always kind of lost on the water traveling.
Yeah.
But so it starts here, the same amount of current, correct?
Yeah. Everything flows through the first resistor.
Right, so everything goes through the same resistor. And so it's two. So 3 and 4 combined have the same value of current for amperes as 2.
No.
No? Okay.
R2 is the current on this side and the current on this side. Let's not look at the resistor. Just do it like right here. The current measured here and the current measured here is the same as here. Regardless of how many resistors are none or nothing, it's just a flow, it's travel.
Sure, but in this situation it would be 3 and 4 equal 2, is that correct?
Now, current for R2 plus current for R3 will be total current. Or current for R2 plus current for R3, there will be total current. Or current for R2 plus current R5 will be total current.
Oh, that's...
My ruler must not make any sense.
Yeah, sorry. I really want to follow this stuff.
Here's R2 is over here, and 3, 4, and 5 is over here. This is just think of it as flow. Whatever is coming in here, it literally splits and comes back together.
Right.
So I was using the term water wheel. All 3, 4, and 5 water wheels are turning the same.
So, if this was 10, this is making numbers up here. If this was 10, 5 would go through here?
Not necessarily.
Not necessarily.
This could be just a little trickle. This could be 1,
Okay.
which would mean this would be 9. It doesn't matter how many resistors are.
Okay.
How about this? I'll just get rid of it. If I have 3 units flowing down this side, then I have 7 units flowing down this side.
Okay. So yeah, it doesn't necessarily have to add up with each other, right?
This side and this side will add up to that.
Oh, regardless of resistance.
Regardless of resistors, it's just flow. Those resistors are like a water wheel. I can put as many water wheels on there as I want. They're all going to turn the same speed.
Well, I'll talk about this one through. That makes more sense doing that. This lane and this lane equal.
Yeah. So you got 3 little campsites right along here. If they were water wheels, they'd all be turning the same. I could keep adding water wheels. They're all going to turn the same.
Okay.
Because that's how much is flowing down that side. If I were to put a restriction on the water wheel and intentionally slow it down, then they're all going to slow down because I'm restricting the flow of the path coming from. Yeah, which up here, if I restrict the flow over here, then it's going to its more is going to start working its way this side.
Okay, perfect. That makes sense. I'll talk about this problem if I have any questions. Thank you. Chris, do you still need these papers?
I got one.
I got both. What's that?
Okay, so we're right now we're getting ready to do the first one on top. We did the second one first.
Okay, great.
And you can do the first one, and you guys can compare, or we can go over it. But I'd do the first one since that's what we're working on now.
Well, since we're coming behind on this, we're going to go outside.
Okay. Sure. So did you get a resistance total? What did everybody get for resistance total? 7. I got 900. Nice. So I hope everybody got 900. I'm crossing my fingers.
No, you didn't.
Did you get something other than 900? Yes, no? Okay. So that'll give us, we can now figure out what current is for the whole circuit. What was that? So it shares with two other resistors, right?
R1 and R6.
1 and 6. So what that's done for me is now I can figure out volts for R1 and R6. Are we ready? What's the voltage for R1?
9.1.
9.1? And R6?
4.6.
4.6. So I'm going to go back over here. Move that aside for now. So I've got,
You got 931.
okay, well, if you got for voltage for the first one, so you've got a different, you have a different amount of current.
I put .0266. I'm not running it.
Okay, that's fine. Yours will actually be more accurate. So we'll, since most people only went that far, we'll do 9.1. It'll still work out, and we got down here, right, 4.6.
Yep.
So that middle section, how much have we got? 10 volts. Everybody with me so far? We had enough information in our grid for R1 and R6 to get our voltages. So that 9.1 is the top half, the top part with the one resistor, and R6 down here is 4.6. So the middle section, which is pretty much almost pure parallel, is 10 volts. So now we know R2's voltage, right? Now these three voltages combined will equal 10 volts. So how do I move on from there?
I multiplied. Oh, wait. I divided the.
Find the current at number 2, at R2, find the current.
Let's find current for the left side, R2.
14.69.
0.006.
Okay, so now that gives us the current for the left side.
Yes. The entire left side, right?
Anyone still confused by the current and the number of resistors? Because it just occurred to me when I was explaining a few minutes ago, I should just draw the river without resistors. No resistors. So we subtracted the total, which was 0.026, and we know down this side we have a flow of 0.006. So what do we have down the other side?
0.020.
0.020. Roughly, yeah. So where does that 0.020 go? What resistors see that current?
3, 4, 5.
3, 4, and 5. Now you have now enough information
Yeah.
to finish it.
But
Yeah, wait, how did you?
You did 10 divided by 250, you got 0.02.
Once I know how much is flowing, we got our total current, and we got the current over here because we got that 10 volts,
Okay, yeah.
and we got the 1500. So now what's flowing down the other side, and we had 3 resistors along that path, and they all see the same current.
so in I do 0.026 times 175. I was working with 4.55, and then all my numbers turned out to be like the current for R2 was 0.0069, and then all down was
Okay, so you were closer to
0.191.
0.007.
Right, and then all down was like 0.191 versus 0.2.
Okay,
So is that gonna be a problem on
No,
the test?
No, what you're gonna find if you do that, your voltages will be a little different, but they're still gonna add up to your
Yeah, cause there's
total.
like a 10.32 in mine and stuff like that.
Yeah,
for-
you're still in there. I can tell.
Okay,
If you do the math wrong, it's gonna be way off. If you're just a couple decimal points or a couple places behind the decimal.
So it's always gonna be the total, it's gonna be the in and the out, the same as current.
You're looking at current,
Number R1 and R6 is always gonna be the same as the total,
not necessarily. If they're out here by themselves,
right?
as long as I don't bypass, if I come in here and put another resistor alongside R6, now it's gonna share the flow. So the current will drop here.
Then you have to add those.
And
for
then I'd
R1
have to add these two together.
or R1.
This wouldn't necessarily change, no, but these two combined would add up to R1. Does that make sense? So basically, this would be two paths come back together and split as two paths again.
But you're not gonna do
And those two would add up to that, and those two. So that's why R1 and R6 are the same current.
that, so. Then we're gonna add these two.
I'm guessing you guys pretty much